Hello, I'm Galen Evans with the World Bank Disaster Risk Management Team, and I'm going to talk about a public domain aerial imagery collection we conducted and sponsored, along with some crowdsourcing products that are brought out of that and the whole process associated with that. And we have a slightly different approach than we're not really involved in direct recovery. Our main focus is after the earthquake, we really needed a rapid damage assessment so that we could start figuring out how much aid is going to be needed for reconstruction and also reconstruction planning so we can really build back better. And that was our main focus, which gives us a slightly different perspective. And in the end, it resulted in the joint damage assessment, which our colleagues at JRC talked some about, and we worked with the UNISAT and the Joint Research Center, and UNISAT put together a really great joint damage assessment atlas. But I'm going to talk some more about the crowdsourcing approach that happened there and what's involved there. So immediately after the earthquake, we had a couple different options. You could do a ground survey, which is really accurate, but it's relatively slow in a timescale of months. You could guess, but that's not really a good option. And we could also do like a remote damage assessment, which is really good, but you need really high quality imagery in order to do it accurately. And what we found with the different options for remote sensing data is for earthquakes and doing building by building damage assessments from earthquakes, satellite imagery really doesn't work. Aerial imagery is a lot more accurate, and oblique angle, like pictometry style imagery, is the most accurate for remote sensing data. But in the sense of time, we ended up going with doing an aerial imagery collection. And so a period of 7 days from January 21st to the 27th, and the plane was flown doing imagery collection over Haiti. It was just 9 days after the earthquake, and it was done in conjunction with the Rochester Institute of Technology. And it collected a lot of data over the entire affected area from Port-au-Prince west to Petit Goave, Grand Goave, and Jacmel. And it's not as easy as it sounds to do the imagery collection. There's a lot of problems with getting there. There's export restrictions and flight permissions and all that stuff. And one of the big lessons we learned is you have to keep the guys with the guns happy. And we also had problems with having to change space for operations and data transfer, transferring data overnight via internet too. And here's some of the examples of the imagery that was collected. In the top right corner, you can see from the LiDAR images collected, basically a 3D map of the presidential palace and some other areas of really high quality aerial imagery. You can see the real definition that you're able to get from that type of imagery. And so, but the question there is, how do you analyze terabytes of information and with a quick turnaround time? Using traditional closed systems, you really can't. There's no real way of getting it there. So we ended up realizing that we had to come up with a different approach and use a different system. So the system we decided to approach was kind of distributed and use the crowd. And the approach we're using is breaking it up into 500 by 500 meter grids and sending it out to earthquake engineers. And as you can see some examples of the grids there over Port-au-Prince, which really makes it into a manageable size piece for different users to use and different people to analyze and assess. There was one problem. How do you find hundreds of earthquake engineers to volunteer on short notice? We ended up working with the Earthquake Engineering Research Institute and the Earthquake Engineering Field Investigation Team to create this community called GeoCan, which is over 600 people with 131 organizations in over 23 countries. And they went out and they analyzed the imagery. And as all of you know, people really want to help. And one thing about GeoCan was it was using crowdsourced domain experts. These are people who are earthquake engineers. They've been in the field, they've done these things. But people want to help, but they can't all go down to Haiti and work. So it's a way for them to contribute and make a real difference from their own home in an area applying their own expertise. And it was really quick. We had analysis happening while we were still flying the imagery and still conducting the imagery, and just days after the earthquake, analyzing, giving initial estimates for the area of Port-au-Prince. And you can see there some of the timeline of when the initial assessment was happening in the Port-au-Prince area. And it gave us some important results. About 50% of the building stock we found were damaged, and it was done by building assessments, looking at the building footprints and the similar damage scale that was talked about earlier. And it gave us an initial basis from which to conduct additional assessment. And there was a lot of things that it helped feed into. And we've had a lot of value by putting the information and the imagery in the public domain. It allowed anyone from beyond ourselves to go and use it and process it and make additional work and create additional value added out of the product, which really wouldn't happen if we just used it in a closed system and just kept it internally. And it created a really good value for us. One example is a natural hazard assessment, which was actually conducted by a team we had down in Haiti that looked at various natural hazards, whether it's flooding, earthquake, other things, and they used some of the imagery collection there to do flood analysis in other areas there. And there was a bunch of, and it's been used in the reconstruction planning right now. Also, a bunch of different organizations used the imagery. Purdue University did some original rubble estimation. RIT did some really cool things where they looked at the blue tarps, which are used in the IDP camps, and used automatic algorithms to detect where these blue tarps were to get some ideas of where displaced persons were. And the USGS used the LiDAR imagery to do a fault line mapping. And there was also ground assessments being conducted with the Ministry of Public Works, UN Ops in Haiti, and the idea there is really getting people back in the building. So you can't, with a remote damage assessment, say an engineeringly sound, this building's safe to go back into, but the damage assessment helped give some prioritization to the areas. And OpenStreetMap as well, they used a lot of different data sources, but I know they also used ours for doing some of the mapping. As you can see the image there, again, with the World Bank Situation Room of the Haiti map. And there was a lot of people that did a lot of stuff and a lot of contributions to the effort. And it was really remarkable, and it helped change perceptions even within our organization and a bunch of others. And there's more people to thank than I could say in this time, but one big thing is ImageCat Inc., who are our partners there with Ron Aguchi, worked tirelessly on that. David Lalamette and the ground assessment, Sergio Moore and the multi-hazard assessment, a lot of other people. And I just wanted to thank you, and it's been a great pleasure working on this over time.